Hello everybody. Next, we will discuss in this video another case of electric dipole, the electric field due to electric dipole at a different point. This is the situation where we consider a dipole, electric dipole. This is charge minus q, this is charge plus q. This is the midpoint of the dipole. We want to calculate the electric field at a point P which is just perpendicular to the midpoint O of the electric dipole. Now, to determine the electric field at this point P, we have to find the electric field at this point due to the negative charge as well as due to this positive charge. Now, if we consider there is a positive unit charge or unit positive charge, then this positive charge plus q will repel this unit positive charge along this direction, and this is the electric field due to this positive charge plus q. This is, say, E1. Again, this negative charge minus q will attract this unit positive charge along this direction, say this is E2, that is the electric field due to this negative charge at this point is E2. Now, this angle theta, this is the angle theta. What is the angle theta? Angle theta is nothing but the angle between the dipole and E2 as well as the dipole and this, say, E1. Now, both E1 and E2 have two components. First, consider electric field E1. E1 will have two components. First is along this direction and the second is along this direction. This angle is theta, so this angle will also be theta. This angle is theta, so this angle will also be theta. Now, the component of E1 along this direction is E1 cos theta, and along this direction will be E1 sin theta. Now, the component of E2 along this direction is E2 cos theta, and along this direction is E2 sin theta. Okay. Another point, I have forgotten this. The length of the dipole is 12. Now, the electric field at P due to plus Q is E1 is equal to 1 by 4 pi epsilon 0 into Q by we need some name to denote these directions. Let this point is point A and this point is point B, and this is we have already done. This is point P, and this is the midpoint or the origin is O. Now E1 is 1 by 4 pi epsilon 0 Q by this length BP square, and the electric field at P due to minus Q is E2 is equal to 1 by 4 pi epsilon 0 Q by PA square. Look at the triangle carefully. This length and this length are same, so BP and PA are similar or are equal. So the magnitude of E1 and E2 will also be equal. Okay? Why? Since BP is equal to PA. Better take this as magnitude. Now you can see here that as E1 and E2 are both equal, then E1 sin theta and E2 sin theta will also be equal, but their directions are opposite to each other. So E1 sin theta will cancel out E2 sin theta. Therefore only the component E1 cos theta and E2 cos theta will survive. So the net electric field at P will be E is equal to E1 cos theta plus E2 cos theta is equal to 2 E1 cos theta. Is equal to 2, the value of E1 is Q by 4 pi epsilon 0 into 1 by the value of BP or PA. Look at here. The length of the dipole is 2L. So this length is just L. Okay, this is theta. This is R. Sorry, this is R. Therefore this will be R square plus L square. Therefore this length will be R square plus L square, R square plus L square. Now what is cos theta? Cos theta means this by this, base by hypotenuse. So L by root over of R square plus L square is equal to 2QL by 4 pi epsilon 0 R square plus L square whole to the power 3 by 2. This is the net electric field. Now in terms of the dipole moment, we can write the electric field E is equal to P by 4 pi epsilon 0 R square plus L square whole to the power 3 by 2. Now special case. When R much greater than L, then E is equal to P by 4 pi epsilon 0 R cube. Now a very important thing you have to remember here, that the electric field due to this dipole at point P will be along this direction, which is just parallel to the electric dipole. Look, this is the electric dipole and the direction of the electric field or the resultant or net electric field is along this direction, or that is, this is parallel to this. Okay, so this is a very important thing you have to memorize or remember, that the electric field due to this dipole at the point P will be just parallel to the dipole for this case. What is this case? The electric field at a perpendicular distance to the dipole. Okay.